Okay, we should be live then. Welcome everyone to this talk today. We have an introduction to MATLAB from Andrew Mazalkov. Andrew is a second year general engineering student who is going to introduce you to MATLAB, how to get started in programming. And yeah, MATLAB is a software which I use personally as well. As a math student, I'm using MATLAB to explore the topic of chaos and make really detailed plots and explore the numerical side of it in great detail, and it's just very useful. So over to you, Andrew, for more information.
Thank you, Jan. Okay, I'll just present and get the PowerPoint up. Right. Hello everyone. I'm Andrew, as Shannon said, second year general engineering student, and I've been using MATLAB for just over a year now. I also heard some of the sort of jokes about it before I came to university. Then I did a few labs in it, really enjoyed using it, to be fair. It was a lot easier than pretty much anything I'd used before. And yeah, here I am now. I'm the MATLAB student ambassador for the University of Warwick for this academic year. And this presentation is going to be basically just a very general overview of MATLAB. So this is aimed at beginners to both MATLAB and programming in general. So if you haven't used MATLAB before, you've never coded anything before, you've never done any of that kind of thing, that's absolutely fine. This is just like a very beginner-friendly presentation. And for people who will hopefully want to learn more at the end, there's going to be some signposting to resources to get you started. These resources are brilliant. This is what I used in my first year for engineering, and you'll go very far with this stuff. So for more support and just a wide range of constantly updated resources, you should definitely join the Facebook group. It's the MATLAB at Warwick Facebook group. If you're on a phone, you can scan the QR code that should be on your screen now, or you can follow the link warwick.matlab, or if you're on Facebook, just have a search, University of Warwick MATLAB should be the first one to pop up. And yeah, it's great for further learning in MATLAB and Simulink, as well as doing well in these sort of softwares if you're using them in some kind of module for your coursework or anything. And you'll be able to see any future events that we host, and there's also going to be a giveaway for freebies. I'll explain a bit more about that at the end, but basically, if you're watching the stream now and you want to join the giveaway for this stream right now, we've got a pretty cool MATLAB baseball cap, we've got t-shirts, screwdriver sets, lots more. Just drop a comment in the live stream saying giveaway or something, and I'll pick 5 people at random at the end. Make sure to do that. And I mentioned Simulink, and if you're confused about what Simulink is, that's completely fine. We're only going to talk about it very, very briefly today, and it's pretty much just a program to run and simulate real-life situations. So when you see the word Simulink, or I say Simulink, just think a tool that you can use to simulate something. It's literally just simulating things, pretty much. And yeah, again, please join the Facebook group, for the giveaway. Use the QR code, use the link, and if you want to join the giveaway for this stream, yeah, just put giveaway or just make yourself known in the YouTube chat. Okay, so here's a quick run through of what we'll be going through today. So we're going to kick off with something that's probably on a lot of your minds right now. What actually is MATLAB, if you haven't heard of it before? And then we're going to look at a short demo of analyzing how efficient certain vehicles are with their fuel. I'm sure, as you know, climate change, this is quite a critical issue right now. We need to be thinking to ourselves, if we have vehicles that are still using petrol, how many miles per gallon are they getting? How far are they going on this fuel? That kind of thing. And this involves importing data from quite large Excel files. You're not going to see any of that. That's all in the background. We're going to visualize this data and fit a curve to it. And then finally, we're going to make an app, and it's not going to be like your typical smartphone app. It's a MATLAB app, but it's one that you can export as a standalone program and share with people who don't have MATLAB, if you so wish. And then to finish off the presentation, short and sweet, I'll be introducing you to some resources to get started with. They're made for complete beginners, so if you've never done any programming before, you've never done any sort of maths, for a few years, definitely try these, definitely worth the time, highly recommend it. So, what is MATLAB? Finally, getting to that part of the presentation. It's a technical computing language designed for matrix operation, and it's the basis to most modeling and computing. So modeling is basically taking a real life situation, which can be really complicated, like lots of things going on, and you're basically saying, okay, I can represent this real life situation with loads of maths. And you do this in MATLAB with something called matrices, which is the plural of matrix. And this is basically just grids that can store different numbers within them. So if you've ever played Sudoku, you have like a big board, sort of 9 by 9. So kind of think of it like a Sudoku grid, but each box has to have a number. And if the box is empty, you can't leave it empty. You have to have something. So you just put a 0 to sort of say, okay, this box is empty. But as you can see, so this is an example of a matrix, and it's basically just a box of numbers. And the brilliant thing about MATLAB is they've been developing it for decades now. They've gotten very, very good at calculating stuff with these boxes of numbers, these matrices. That makes it good for stuff like research, simulation, computation, modeling. And if you're a first-year engineer watching this, you're definitely going to be using this in term 2, and it's worth just having a think about it now. And there's also something called an interactive development environment, or IDE for short. And it allows you to analyze data, visualize data, develop algorithms, and deploy application tasks with minimal effort. So to some of you, that might not make a lot of sense. To people who are doing sort of maths or computer science, you'll come to find out this is very, very useful. There's also a very large support community run online. I'll get onto this more at the nearer to the end. This community is brilliant. If you have any issues with MATLAB, you have 24/7 access to experts around the world who are using it in industry, and you're pretty much guaranteed an answer to your question if you phrase it properly and you've got like good documentation and stuff. And we also have the Warwick MATLAB Facebook group, which again, I can signpost you to some places, I can signpost you to resources, and it's just a good place to stay updated. So in total, MATLAB is used in over 20 industries, and these range from aerospace and automotive, which some of you may have quite a lot of interest in, to biotechnology, energy production, financial services for the economics and business students, medical devices, and even railway systems. So we've got stuff like industrial machinery, communications, semiconductors. It's used pretty much everywhere. And what about some of the companies that use MATLAB? We know about the industries, but what about the companies themselves? Let's take a look at some of these key companies that use MATLAB and see if you recognize any. So that's quite a list, just a short overview of the companies that use MATLAB. And around the world, there's millions of engineers and scientists using MATLAB and Simulink. In fact, there's over 4 million users of the products in 185 countries. That's a very, global reach. The software is used at over 100,000 businesses, governments, and universities around the world. And pretty much all of the top automotive and aerospace companies use MathWorks products, be that MATLAB or Simulink. So yeah, knowing MATLAB is a game changer when looking for a job, as the former senior vice president of Google will tell you. Okay, so now that we know what MATLAB is used for and where it's used, let's take a look at how people are using MATLAB to advance the world around them. Again, don't worry about not knowing any MATLAB. This isn't a requirement. Just keep in mind it's basically a technical computing language that makes doing maths easy. That's all it's used for, pretty much. So here's an example of a real-life application of MATLAB and Simulink to an aerospace problem. So going back to earlier, MATLAB was used for the mathsy parts, anything that's equations, solving numbers, anything like that. And then you can use Simulink for simulating things. So the challenge was to design a guidance, navigation, and control system that allowed this sort of aeroplane unpiloted spacecraft to land and come to a full stop on a standard runway without either power or a pilot. Something which is insanely complicated. It's literally rocket science, you know, very difficult. So the solution they went for was to use MathWorks tools to streamline software implementation. So basically programming stuff in a much easier way. And they could shorten the design to software to verification cycle, which enabled them to make late changes, which if you've done any kind of programming with GitHub, version control, stuff like that, this can be a big pain sometimes. And it's very nice to have a sort of tool that helps you improve your processes. And as a result of this, they could rapidly develop within a budget. They had a successful test flight, and there was even a contract to continue development with MATLAB. And as we can see, John was quite chuffed with it. Okay, so moving a bit closer to home now, more in the UK, we look at how University College London applied machine learning with MATLAB. So some of you might have heard machine learning before, some of you may not have done. In a nutshell, and if there's any computer scientists watching, I'm very sorry for this butchered definition. It's basically a type of artificial intelligence where you give a program a whole load of data, just loads and loads of data, and then the program decides how it's going to learn from this data. And if you want to explore machine learning in MATLAB further, there's an machine learning Onramp course, and I'll get more onto that later. So this time around, their challenge was to develop algorithms that can predict the onset of epileptic seizures based on human intracranial, and then I always struggle to pronounce this word, EEG recordings. And their innovative solution was to use MATLAB to extract features from the data, basically like trends or something common that's happening in the data. They would identify the best classification models, which is basically saying, how do we group parts of data to make sense with what we kind of have now? And they combine their models to maximize prediction accuracy. So anyone who's done any kind of machine learning, deep learning before, accuracy, very important part. You've got I think it's the confusion matrix. You want to make sure that your model is as accurate as possible. It's not overfitting, it's not underfitting, it's not overdetermined. So it's a very important aspect. And their results, they created a model for predicting epileptic seizures for multiple patients. They could develop algorithms that won first place for individual participants and third place overall in a worldwide Kaggle competition. Kaggle's a brilliant website as well for learning machine learning. Highly recommend going on it if you're new to programming. And they halved the computation time by simultaneously processing training and test data on multiple cores. So this is more in the realm of distributed computing. Maybe some of you are aware that computers nowadays are quite common to have quad cores. And I don't know, a few years ago, they were like dual cores, they had 2 cores. So when you're processing a very large amount of data, you want to try and split this data up onto as many different cores as possible. So that way your computers are working more efficiently. However, this comes with challenges of its own, but it's something that MATLAB deals with quite nicely. And there's a quote there. He's mentioned some very maths-heavy techniques. For the keener participants, this is all available to learn on the MathWorks website. But to be honest, some of these words I don't even know. This is very, very advanced stuff that MATLAB's being used for. And finally, a company I'm sure we've all heard of before. So this is Tesla, been in the news a lot recently. Elon Musk has been in the news a lot recently. You know, word spread about Tesla. And they faced the challenge of developing a 100% electric production sports car on a limited budget. So they wanted a sports car. Cool, fair enough. They wanted it to be 100% electric. Okay, slightly more challenging, but you know, we can probably work around this, we can deal with this. But it was on a limited budget, which when it comes to these kinds of projects, you kind of just want to pour as much money in as you can and just hope the answer comes out at the end. So this was very tricky. And in the end, they decided to solve this problem with MathWorks tools to do something called model-based design, to model and simulate the vehicle, analyze its performance, and evaluate design trade-offs. So this basically means if you're designing a car, you want to have it be strong. You don't want it to break if it sort of goes around a corner too quick, if the forces are too strong. But at the same time, you don't want to put too much metal or material into the car, because then the car is going to be slower. It's going to be less fuel efficient. It's not going to be as good for the environment. So you have a lot of trade-offs here between making the car last a long time and making the car more environmentally friendly, making it recyclable, making it just more efficient in general. And yeah, so their results, they calibrated their system model, improved in simulation accuracy. They had hundreds of powertrain configurations tested without using physical prototypes. If you've ever worked on cars before, being able to test these configurations without the prototypes is like just next level useful. And multi-domain effects simulated, enabling dramatic advances in battery technology. So yeah, battery technology is like a huge thing in research right now. There's a lot of R&D going into battery technology for electric vehicles, and this is all possible with MathWorks. And then there's a quote from two people from Tesla Motors who couldn't have done it without MathWorks tools, and they're going to rely on MATLAB and Simulink in the future to help make informed decisions. So you can see it's played a very important part of a project in a very well-known company, and it's the useful features that are just in MATLAB that make it so prevalent in so many industries. And that's what also makes it very useful to learn as a student, because it's quite likely you're going to end up using it in some form if you go into this kind of business when you're older. Okay, so to solve problems, many engineers use something called a technical computing workflow. So this might not make a lot of sense right now. You can just think of it as a sort of generic project you may have done before. You get some data or information, you measure something, you just get some numbers. You then organize these numbers so they're easier to work with, and you have a better idea of what's going on. You do some calculations, you maybe make like a PowerPoint presentation, and then you present it to someone. So your typical project, get some numbers, do something with them, organize them, calculate them, stick it in like an Excel file, make some nice graphs, and you're done. You can present it. So in this particular workflow, people typically access data or information, whether it be from data files, other software, or directly from sensors and hardware. Explore and discover. There's various results with the data using equations, algorithms, or functions. Now, this step could involve visualizing, so making the data sort of nicer to look at, machine learning, sort of an algorithm that learns from your data, or optimization, depending on the application. And optimization just means making something more efficient, making something run faster, more without less mistakes, that kind of thing. And then sharing. So your results or findings can be shared to others through code, reports, or as design specifications. And if you're a first-year engineer watching this, I'm sure you're probably doing the ES192 design project where you have to have like a big A3 poster, have design specifications on it so other engineers can look at it and be like, okay, this makes sense, we can build something from this. So this process is a repetitive cycle regardless of the application. And for the best results, it has to be repeated many, many, many times, and it gets slightly better with each version. And luckily, with MATLAB, this workflow can be automated to save time and errors, and a lot of frustration down the line. So with MATLAB, we can take this complicated, messy workflow, a lot of things going on, a lot of repetitions, and we can just make it so much easier, so much nicer to use. And now we're going to have a quick look at the demo mentioned at the beginning, where we're going to look at the relationship between fuel economy, basically fuel efficiency, horsepower, the power of the engine, and the type of vehicle. And as I said, the program does this by taking a lot of data from Excel, interactively visualizing and exploring trends, basically trying to find patterns to the data, creating a model, so a mathematical representation of our data, and then documenting the results so we can look at them later and we can go like, yeah, okay, this makes sense. We can do something useful with the data we've gathered. Okay. All right, has that come up?
Yeah.
Okay, awesome. So, like I said, this isn't anything you have to learn right now. Don't worry about the instructions, the code. This is just a sort of generic presentation. So basically, we've got some data that we're taking in, and we're displaying it. We're doing some calculations on it. We're putting it into more tables. The visualization using the plots tab. So MATLAB basically plots the data for you and makes it look nice and pretty for you. Detailed plots. Yeah, like I said, we've got a plot here. And probably one of the things MATLAB is very useful for in sort of everyday projects is curve fitting, where you just give it some data and you say, look, I want to fit a curve to this. I want to have a good idea of what's going to happen with this data. And that's how you can do it. And there's some instructions on the curve fitting tool. And so here's a graph that basically says, if you're driving a car with a certain miles per gallon rating, so basically how far are you going for how much fuel you put in, and then your engine has a certain amount of power. So each of these tiny blue dots is basically a data point. So someone's gone out and they've measured it and they've put it like into a table or something. So we've got the blue dots here. And then we say to MATLAB, okay, we've got loads of data. We don't want to sit here and calculate this. We don't want to have to think of a way to fit this data to a model. So what MATLAB does for us is it calculates, it's called curve fitting. It basically calculates the best possible solution to all of these blue dots. So now you can say, if I had a certain engine being used in the city with a certain horsepower, if I wanted to then know how many miles per gallon it would get in the city, I can just look at this red line and say it was 400 horsepower. I could say, okay, it's probably going to get about 20 miles per gallon based on extrapolation, which means sort of inferring from the red line. And then we can plot the results. And one of the brilliant things about MATLAB is the help function. So you can just type in help plot and it will come up with loads of instructions on the plot function. So if you're coding something in MATLAB, and let's face it, if you're learning a programming language, you're not going to remember everything. Like even the most advanced programmers, they don't remember all of the functions. And you can just type in help and then the function, it comes up with some documentation right there, no hassle, no Googling, no time spent trying to find answers. And it's basically all there. And there's also a documentation command, but I won't get into that for now. And another useful feature of MATLAB is prediction bounds. So again, using curve fitting, you can say we have a data set, but it's kind of limited. We haven't really measured data above and below this collection of dots. So then MATLAB can say, okay, I'll fit a curve as to where I think your data ends, so that anything you decide outside of these sort of boundaries, you can just say, nah, that's probably not right. That's an outlier. We need to remeasure that. And as I said earlier, there's an app designer. And I won't get too much into the specifics of that, but pretty much you have your graphs, you have your data, it's done all of this, and now you can build an app. So basically, I'll just open it quickly. So all of that stuff that we've done, it's called a MATLAB live file. And if you start using MATLAB, if you do the Onramp, you'll soon learn the difference between live files and sort of regular files. But you can take all of this information, all of this code, and you can put it into an app, like a MATLAB app. Okay, so hopefully that's popped up. And it's just going to take a little while to load, because if I'm live streaming this, then MATLAB's not going to run quite as quick. So I'll just go through this quickly. do you maybe want to talk about the stuff you were using MATLAB for, Shannon, while we wait?
I think it would be tricky if I switch screen. It'd be more complicated. But yeah, just to mention to the audience watching, if you have any questions, just pop them into the live chat and we'll have a look at them at the end, if that's right. How's it looking now?
I think it should have loaded by now. It's just taking a little while. So yeah, Chrome's using quite a lot of the processing power of the laptop, because I'm on a laptop, so if you were running MATLAB ordinarily, it would run way, way faster than this. But this is your app designer. I'm not going to mess around with it just yet, but you can basically drag and drop components and encode them. And once you're done, you just run it. So all of that file you just saw now, we've basically taken all of it and just put it into an app. Nice and simple to use. Drag that over. And all of those plots that we saw MATLAB do for us, we can now just click a button and have it be done, as simple as that. So it'll just take a second. So in this case, what the data is doing is it's looking at cars. So if you have cars and trucks, it's looking at cars, and then driving on cities or highways, so driving in cities. And it's looking at the relationship between the horsepower of the engine, so how powerful the engine is, to put it simply, and how many miles per gallon the car is getting. And yeah, you can just have like a nice plot of the efficiency and stuff like that. And then you can choose it for different years. You can look at cars instead and on highways. And so this thing, it stands for confidence interval. It's pretty much how confident MATLAB is that it's fitted the curve correctly to your data. And if we put it at 80, we can see it will be a tiny bit different. Oh yeah, I need to select trucks. And yeah, you can put error checking into your app. So if you want an end user to use your app and you only want them to have like certain choices that they can make, you can also put in error bars. So yeah, we can now look at, in 2004, if this was the sort of average horsepower of a truck on the highway, how many miles per gallon would it get? And yeah, okay. So now, I will quickly demonstrate just how easy it is to make one of these apps. So if you have MATLAB downloaded, you can go on the home, new, and then blank app. Okay, and hopefully this will work, and I'll close this one for now. So if anyone's sort of done any maths or remembers any maths from the past few years, you have the sine function, which is essentially just like a wave on the graph, and we can basically make an interactive app that does this. So you have a component library here, which is basically the interactive boxes that you want to put into your app, and then this will be the sort of screen that you see. And then you can go on slider, put it somewhere there, make it a bit longer so we have more choice over it. And now we're going to say, okay, so this slider represents gain. Gain basically just means multiplication. You're multiplying by a certain number. Okay, and then we want to set the limits of the slider. So as you can see right now, it's going from 0 to 100. That's not really what we want from it right now. We're going to put it to between -10 and 10. So I'm interacting with the app designer, and I'm saying for this slider, I just want it to slide between -10 and 10. No coding, no faffing around with anything. Okay, and then we can go on the axes, and we can say to this, okay, this will be our sine wave. And then for the ruler, which is basically, yeah, again, this is just some like other stuff that we don't really need to concern ourselves with right now. But on this axis, there's like, it goes from 0 to 1 with something at 0.5 in the middle. we instead want it to go from, again, -10 to 10. So now the ruler on the y-axis, this stands for y limit, it's going between -10 and 10. Okay, so this part's like a little complicated, but it's fine. Like, you don't have to know how to do this. So we go on callbacks, and this is how we get our program to interact with user input. And we add a value changing function callback. Okay, sorry, I have the code here. So we say we have a vector, and a vector is like a matrix, but it's just like a line of numbers, essentially. Yes, we say, okay, we have a vector x, and we want it to take values between 0 and 2 times pi. So what this function does, linspace, it just generates loads of little values for x between 0 and 2 pi. And then we go, okay, so we've got our x, and now we want a y value because we want to plot this. So we say our y value is our changing value. We said here, changing value is what the user inputs, pretty much. So whatever the user inputs, this changing value, we multiply it by the sign of our x. And that creates like a new vector. And then probably the most used function in MATLAB, plot. So we now say we want to plot our data. So within that app, on the user interface axes, we want to plot our x and our y. Okay. Yeah, that should be good. And then we save it as sine wave. So that probably seemed quite complicated. Again, you don't have to know any of this. It's just a very quick sort of rough demonstration of what it can do. Then we run it. Okay. So here we have our little slider that we renamed to gain, and here we have our sine wave. So if we put the slider to 10, we have 10 sine x, because we're taking the user input of gain and multiplying it by sine x. So as you can see, it goes from 10 to -10, amplitude of 10, 10 sine x. We can make it -10, so it's the same as the 10 slider, it's just been reflected, which is what happens when you have negative sine x. And we can put it between 0 and 1, and that makes it nearly flat. And yeah, we can just mess around with it. And I won't do this now, but you can also export this. So say your friend doesn't have MATLAB, but they want to be able to use this sort of little app you've created. It's very easy for you to just take this app and make it a program that anyone can run, whether they have MATLAB or not. However, we don't have time today, so I won't get into that. And yeah. Were there any questions in the chat?
Yeah, so thank you, Andrew, for your insightful talk. We had a few questions. So from Mikaran, wanted to know, how do I model yaw control for a wind turbine in Simulink?
Oh, okay, so that's our second year design project.
Okay. And
honestly, I'm still learning that at the moment, and I could do a tutorial on that at some point in the next few months, but that's quite advanced.
Okay, sure. And another question from Lincolnshire Rocker. Will this work on my MacBook Pro? I should think.
Yes.
Yeah.
Yes, it definitely will.
Yeah. Okay. And from Thomas Fernandez, if you train a model in MATLAB, can you export it to use it somewhere else? I think you already mentioned that you can. Or does MATLAB have an API to interact with other languages?
So I'm not going to be entirely accurate, but there is stuff in MATLAB that you can use to export to C code. And in fact, in the MATLAB Facebook group for Warwick, I posted an article to a way, I think I posted it in the last few weeks, where you can basically take your MATLAB code and it will generate C code from it using some of their software. But if you message me or something after the talk, my information will be at the end. I can guide you to some more resources, but I'll look through some support communities like in the next few slides for that question.
Okay. And just a question from me, how did you get into programming?
Okay, I'll make it quick because this could drag on a fair amount. But
sure.
I mean, my first, I think I was like 11. I got Minecraft. You know, typical kid. Minecraft is like becoming popular on YouTube. You just want to check it out. You want to play it with your friends. And it was made in Java, and I wanted to like, I don't know, just mess around with it. So I tried learning Java, and that was like completely over my head, and I had no idea what was going on, and I just gave up. I thought programming's not for me. Like, that's fine. GCSE computer science. If anyone's done GCSE computer science, I'm sure you know how painful the programming coursework is. Again, I was like, maybe programming's not for me. Like, this coursework is just not fun. Did it at A level, did it up to AS. Luckily didn't have to do the programming project. Again, I'm just thinking, you know what, maybe I'm not a programmer. I'm not that kind of person who's like good at this kind of stuff. And then I came to university and I was like, okay, we're going to be doing some C, we're going to be doing some MATLAB. I'm not the best at programming. I'll just knock it out and like be done with it. And I don't know, I think when you start learning it in a much more open environment, such that it's being properly taught by lecturers, it's just so much more enjoyable than having, I don't know, YouTube tutorials that don't work or like stuff that just doesn't make sense. And I wouldn't say I'm like good at programming now, but it's a lot more enjoyable than it has been sort of over the past few years.
Okay, that's interesting. I mean, for me, and for many others, we can relate to how difficult it is to learn programming just by ourselves. So thanks for that. Yeah, do you have another slide?
Oh yeah, I'm just halfway through, but this next stuff will be quick.
Oh yeah.
And I'll just say before I go on that I don't want to sort of exaggerate too much, but I actually do think it was the learning experience of MATLAB that these online courses were just so straightforward. There wasn't this whole like, oh, you have to import modules in Python, you have to like build classes. It was just, you know what, here's your language, like just go and do it. It was just such a breath of fresh air. And I think it's definitely what got me into the student ambassador role, that I just enjoyed it so much. So yeah. And okay, I'll just carry on then. So the demo we looked at is just one example of the technical workflow. So in the demo, we access data from Excel files. You didn't see it, but it was like happening in the background. And we explored some visualization options using the plot tabs. We used the curve fitting tool, again, just happening in the background. We used the curve fitting tool to explore different fits that could apply to the data. And then we went through how functions and apps could be further used to analyze the data. So that was basically, we can make an app and we can see the data and then we can share it with other people. And share. So yeah, we can export our MATLAB scripts as reports. So you can generate a PDF using the results from your MATLAB code, something which is just invaluable in industry. And we can also share the apps as standalone executables, which is basically just big words for if you don't have MATLAB, you can still run this. So with all the tools that MATLAB offers, there's many ways to tackle this workflow. And we don't have the time, I won't go into them now. So let's take a look at the other ways you can use MATLAB to help with the problems you need to solve. So from the demo, we saw that data files can be imported into MATLAB. That was done through the Excel. You didn't really see it, but I'm sure you have an idea that if you have data, if you have files, then yeah. Or did it just disconnect? Okay. So I'll just reconnect again quickly. My apologies, the other laptop I was using kind of went to sleep.
Sure, no worries.
Okay. I'll be back up in a second.
A question from Val. Do you need to know vectors?
For MATLAB, not necessarily, but I mean, the biggest part of MATLAB is matrices and vector operations. And with vectors, it's quite straightforward to learn. I mean, to get started with MATLAB, you probably don't need vectors, but at some point, you'll just come across them anyway, and you'll just be like, oh, okay, you know, that makes sense. Okay. Does that come back up?
Yeah, that's fine.
Okay, awesome. Apologies for that. So, we talked about data file. Oh yeah, so I'll just quickly answer the question. You don't necessarily need to know vectors, but the MATLAB Onramp that I'll come on to later, it will teach you all of this, like, with no assumed prior knowledge. It's very straightforward. Okay, so from the demo, we looked at importing data files. You can also import audio, pictures, and video files. You can get live data from the internet, whether it's through a database or through cloud services. You can get data from pretty much anywhere, and this allows you to connect to IoT devices to actively read and write data. So IoT stands for Internet of Things, which can be thought of as making everyday objects more intelligent by attaching processors to them that have an internet connection, essentially. So you could be using MATLAB to receive data from a smartwatch, a fridge, or even a satellite in the sky. And you can also get live data from hardware and sensor data, something which is very useful if you're running any kind of live systems where you need to be keeping an eye on things. And if you don't have any hardware lying around, you know, sometimes it's just difficult to get it in stock in places, you can use MATLAB Mobile, which can record your phone's sensor data. So you can record sort of position of your phone, GPS, that kind of thing. And if anyone watching this is interested in electronics and Arduino and that kind of thing, MathWorks very recently released an Arduino kit, and you can use it to teach yourself MATLAB and basic robotics. It's a fantastic learning opportunity, very hands-on. It's just good. And I think I linked it in the Facebook group in the past 2 weeks. Right, okay. And going back to the demo, we saw a few ways that we can analyze and visualize data, and we didn't even scratch the surface of all the available functions for data analysis and visualization in MATLAB. So with MATLAB, you can create heat maps. So if you've ever been on Google Maps, you can see some roads are busier than others. That's like a heat map. You can create contour plots, which is useful for measuring stuff like earthquake, sort of how powerful earthquakes are. Mesh plots, which is useful for matrices. Audio waves, if you're into sound editing and that kind of thing, can be useful. Even animations, the list just goes on. And in fact, the MathWorks logo you see in the top right of the presentation, sort of around here, it can be made entirely from scratch in MATLAB. This logo here. And it's the only logo in the world which satisfies a partial differential equation. And for the maths and engineering people among you, the logo is one eigenfunction of the 3D wave equation, which doesn't even particularly mean that much to me, but it's a cool logo. Okay, so again, as seen in the demo, MATLAB has a lot of powerful algorithms in stuff like statistics and optimization. And these powerful algorithms are put into packages that can be applied quickly by engineers, and they can even be used as building blocks for even more specialized analysis tools. So these sort of toolboxes, there's over 50 toolboxes in MATLAB, and they range from financial sort of services, financial modeling, financial analysis, to automated driving. So if you were feeling brave enough, you wanted to try and make your car drive itself, you could take a look into doing that. And there's also add-ons that are made by the MATLAB community to provide support for applications that the toolboxes don't cover. So, I don't know, maybe you're a scuba diver and you want a MATLAB program, like an add-on that can interact with your smartwatch the deeper you go. If there's not a toolbox for it, chances are someone's made it already in the community, and if not, you can just request it, see what's out there. And with the amount of add-ons and support available from the community, the opportunities to improve the efficiency of your project are right on your digital doorstep. There's just a lot of stuff out there to help with your projects. Okay, so if you're doing any type of testing or analysis, eventually you're probably going to need to share your results. With MATLAB, you can copy and paste the figures, like the little pictures, into other applications, or you could write programs that automatically export all of these figures, these pictures at once. And then you can share your scripts or codes or programs, whatever you want to call it, as reports or online on file exchanges. Maybe you need to upload it for like a module or on Tabular or something. And one of the real benefits of using MATLAB is that you can generate code from your apps and scripts, and then you can share this code with others or deploy it directly onto hardware. So that's going back to the sort of generating C code that I briefly touched on earlier. And even people who don't have access to MATLAB, they can have access to a standalone app that you make. So if you make some code, you're really proud of it, you just want to get it out there and share it with loads of people, you can make a program from that anyone can run, regardless if they have MATLAB or not. Right, so probably the most important part of the presentation for most people watching today, MATLAB Onramp. It's for new users, students, just anyone who wants to explore the MATLAB environment and, you know, take a look at what it can do. It's absolutely free. If you're a Warwick student, you already have access to this. And it offers a very strong, a very good foundation for future learning. And it does this by delivering basic MATLAB skills, and it makes sure that if you're doing it, you're comfortable navigating the MATLAB environment. This course is basically what made me realize, you know, programming doesn't have to be such a pain. It can actually be, you know, quite fun, quite simple to do. And if you're watching and you're thinking, you know what, I just want to get stuck into MATLAB, like after this, I just want to start learning what I can, the Onramp is definitely your first stop. Once you've gotten to grips with the language, you've completed the course, you've done like 100% of it, there's a lot more stuff available. You can try machine learning, deep learning, image processing, and there's much more through like a multitude of self-paced beginner courses. Okay, and if you have sort of more advanced questions, you know, maybe you've tried coming to me and I signpost you to MATLAB Central, for example. This is basically a gathering place for the MATLAB and Simulink community. So members in this community get answers to their technical questions, have a look at code that's been posted, practice their programming skills, and just stay up to date on ways engineers and scientists around the world use MATLAB and Simulink to do their work. If you have a question about MATLAB, whether you're stuck or just wondering what you can make with it in general, MATLAB Central is one of the first places to go. And with such a widespread and diverse community, you'll be sure to receive the help you need. And it's just a brilliant place to stay updated with real industrial uses of MATLAB and Simulink, something which is invaluable to those among you wanting to build your commercial awareness to sort of show employees in an interview. Right, so nearly at the end. To top it all off, here's a few more additional resources you can use to get stuck in. And I'm aware that this is a presentation, so I'll share afterwards, if people want this, I can share the presentation so you can access the links and, you know, just check out what you want. So it may seem a bit overwhelming with just how much content there is out there. And for most beginners watching this session, I just advise you to join the Facebook group. There'll be a link again on the next slide. Access the University of Warwick like homepage on the MATLAB website, get signed in, just use like your Warwick email, and take a look at the MATLAB Onramp. So the MATLAB Onramp, definitely best place to start, and once you've done that, you'll just be able to see everything that's available and sort of go from there. And the time investment of doing these courses will pay back so much in the future. So don't miss out. Just try something, see where it goes, see how you do with it. And yeah, thank you so much for sticking around to the end. I hope you enjoyed the introduction session. Once again, I'm Andrew, your MATLAB Warwick student ambassador. And if you want to contact me, you can go on my website. There's a link to my LinkedIn, or you can just join the Facebook group and make a post in there, message me. And if you'd like to take part in the giveaway, I'll be doing weekly giveaways probably up until around Christmas, maybe further. There'll be more information on that. Again, just join the Facebook group and you'll see further instructions. And for this presentation, we've got, so we've got the cap, is really, really nice. These are, I don't know, quite popular. We've got the drawstring bag, which is quite nifty to have. We've got, let's have a look, playing cards for all of your Ring of Fire needs. Okay, so we've even got stickers for laptops and PCs. There should be temporary tattoos in here as well. Yeah, so we've got some temporary tattoos if you really want to get creative. I've got loads of pens, so yeah, if you need pens, I've got plenty of MATLAB pens. I don't even have to give those away. If you want one, you can just get one. And I believe we have sunglasses in here somewhere. Ah, yeah. Yeah, there's a screwdriver set as well, but I'm not going to look for it because it's just going to waste time. But yeah, the sunglasses are pretty nice. And yeah, so that's pretty much my part done. I'll pick 5 people at random to win the giveaway. So you're going to get like a whole bundle of stuff. And whoever wins, just add me on Facebook or something, because I need your t-shirt size. And we'll have to find a way for me to actually physically give you the stuff, which we can't do for the next few weeks because we're in lockdown. But yeah, any questions?
I think we're okay for questions. If anyone has any questions, make sure you got it in the chat. I'd just like to mention we've got Warwick AI has got a summit on the on Saturday 14th and Sunday, and it's a really exciting program featuring talks throughout the 2 days in healthcare, business, strategic AI, finance, and fundamental AI research. And we've also got a careers fair, which is going to be really, really helpful. So make sure you get onto Facebook and our website as well, and our Instagram. All of those links are in the description. And just keep up to date with that. I think that's all I've got to say. Andrew?
Okay, I tried using random.org and I basically just kind of went through the comments, so I'll just see if I can DM people quickly. Okay, maybe not. Right, so if everyone's in the MATLAB Facebook group, just... Okay, let me just make sure I've got the numbers generated correctly. Okay, so we have Toby Gillespie, Toby. We have Vicky Wang, Jessica Smith, Alice Crocker, Thomas Fernandez, and let me just make sure I've got this right. Aaron? It just said AP Aaron. So I'll put my Facebook in the chat quickly. Right, apologies.
So these are the people who've won something.
Yeah, so I'll put my Facebook profile in the chat. If you add me, I think it's users. Okay. And yeah, so you've got like a whole bundle of stuff that you've won. This is completely free. Let me just make sure if you haven't won though, I've got like so much stuff to give away. So basically just join the Facebook group and like, oh sorry, it's not users, it's user. Okay. Okay, I guess not. I tell you what, just okay. Add me there, Andrew Maz. If you join the Facebook group, I'm also like one of the admins, and I'm the only one posting in it, so you can just add me from there. But I'll just make a last note.
Okay, great. Thank you very much, Andrew. Looks like we've got a lot of stuff to look at with Onramp. It looks really good, especially machine learning and deep learning there. So thank you very much for watching, and see you at the summit.
See you soon.